Okay, so I'm going to talk about cluster ingress in the age of Envoy, Istio, and cloud. My target for this talk is to go a little bit deep dive into the concept of what ingress is in Kubernetes and what's the relationship to load balancers, API gateways, service meshes, and then look a little bit at the ingress controllers or providers that I've worked with and my experience with that and how I see the landscape evolving. So who here is familiar with Kubernetes, using Kubernetes? Yeah, quite a few. Ingress, using ingress already? Okay, not that many. So maybe the first part will be a bit boring. And who was at the talk from Kong earlier about moving your monolithic application to, yeah, all right. I think the talk earlier did a very great overview of how to, why you need an API gateway kind of, and why you want to consider service mesh. So yeah, my name is Vincent. I like Kubernetes. I organize the Kubernetes meetups in Singapore. Has anybody here been there? Yeah, okay. Do you work for Apple? No. Oh, okay. Is it Scott? Yeah. Sorry. All right. Okay, so first, a little revisit of what is a Kubernetes service. So a Kubernetes service is a way to define an endpoint that you can hit, and then it will load balance the traffic that you send into that to that IP and load balance it across your backend service endpoint. So on this slide, the blue little orbs are the pods in Kubernetes, which are multiple containers running together, and or single container, depending on what you are using as a deployment. So a service, by default, if you specify cluster IP, that means it will only be accessible within your cluster and nothing external can reach it. Another option is to specify a service of type node port, at which point Kubernetes will configure, or the kube proxy specifically will configure every single worker within your cluster to open up a port. And if you send traffic towards that port from externally, then that will be routed towards your pods or your backend services running in Kubernetes. On top of that, if you specify a service of type load balancer, then Kubernetes has these controllers that talk to or specific cloud providers. So if you're running a Kubernetes cluster on Amazon or on Azure or on Google, each one of those cloud integrations will then go out and create an equivalent load balancer or a cloud load balancer and point it towards the node port that was exposed earlier. So that really builds on top of the concept of node port service. So the next step is, once you start deploying lots of services inside of a Kubernetes cluster, you can go ahead and define all of them as a load balancer. I forgot one step, which is once you've defined your load balancer, then of course you point your DNS records towards that load balancer, and then all the traffic will be going towards port 80 on the load balancer, and then the load balancer forwards towards the node port of the workers that then gets directed towards your backend services. So if you do this with many services, you're going to start paying a lot of money for load balancers, and that may not be what you really want to pay money for. So the good thing about using for each individual service a service of type load balancer, you will have a reduced failure domain per service because every service gets a dedicated load balancer. So you cannot have one service getting a high traffic, maybe bringing down the load balancer, affecting another service, so it has an advantage, but the disadvantage is, of course, the cost. So in Kubernetes 1.1, they added the concept of an ingress. So it's a way to define how to route traffic towards your backend service. So it's a way to reuse a single load balancer, and we will see more how that works, and we see more about the drawbacks about this ingress object. So let's step back a few steps, and this is probably very easy for everyone here. Initially, when we just have like a single server, single application, you just run your application on port 80, you set up a DNS record that points toward that server, and then whatever traffic goes directly to the server, and it's very simple, not very highly available or anything, but it works, right? So then once we move towards containers, we start running multiple containers on a single server. Now, how do we route all the traffic for foo.com and bar.com towards that one node? Knowingly that web browsers talk HTTP protocol 80 by default, so they should share the same port but handle different web application. So of course, this has been solved a long time ago, originally maybe with Apache or different web application service, but more popularly recently it's Nginx, where you just define host configuration blocks and for every single upstream service. So once you start looking at a Kubernetes cluster and you use an Nginx, for example, you create an Nginx deployment, you expose that through a load balancer, and then you go ahead and create a vhost for every single service you deploy. Now, all of the configuration of how to route traffic towards your services needs to be handled through this one Nginx configuration, and if you are a big team, you need to all collaborate on this configuration and work around conflicts that you have. So this is where Nginx ingress controller comes into play, or in this case, an ingress controller. So Kubernetes ingress provides the concept of an ingress object that you can define within Kubernetes, and it has the following syntax, such as you define rules that define for a certain host, it goes and routes traffic to a service name. So the service that we saw earlier is now only routable within the cluster, so it's a service of type cluster IP, and then the service that you expose to the public is the Nginx ingress controller, which is basically Nginx doing the layer 7 routing, right? So if you're running on Minikube or Kubernetes on your laptop, or if you're running in a cloud provider which doesn't have advanced application load balancers such as Google or Amazon provide, Azure has an equivalent as well, I assume, maybe you just run a simple layer 4 load balancer that directs traffic all towards the Nginx running on your cluster, and then within your cluster, Nginx will route to the individual services. So that's what an ingress controller does. But in this case, we haven't really solved the problem because the ingress definition now is still one big block, and we still need to collaborate and make sure that we can all put our service definition in there. Of course, it's possible to split this up in multiple individuals. So if we deploy a service called foo, we just deploy it together with an ingress definition for foo and a service called bar with an ingress definition for bar. And the ingress controller is what generates and aggregates all of the configuration and generates the Nginx configuration. Now, the great thing about ingress controllers is that they're not specifically bound to, you can choose your own ingress controller. So it can either be Nginx or Haproxy or some other ingress, maybe natively built into Google Cloud. They have a GCE ingress controller, or you could work with Zalando has an ingress controller, Kube ingress controller that works with application load balancers. So instead of using Nginx inside your cluster, you're actually delegating the routing logic outside of your cluster to the application load balancer of Amazon, where then you can use web application firewall and other Amazon features to filter out attacks at the edge instead of letting traffic go all the way into your cluster. So with different ingress controller, you can have a different way of controlling the routing logic towards the services within your cluster. So ingress controllers, we have talked about, they allow us to define rules, and then this results in a proxy controller configuration. So I call it proxy because Nginx here is being used purely as a proxy to transfer or translate the data. On top of that, we can also have DNS controllers. So if we define an ingress object inside Kubernetes, then we have an ingress that has a load balancer. So now whenever we define this, we have the host name in that ingress, or maybe we have a subdomain that we are defining. So we want automatically DNS records being created to route towards that load balancer. This is possible with a DNS controller that also listens to the ingress or service object. On top of that, maybe we want to also do TLS termination. So if we set up, for example, we manage our certificates in Amazon, and we set up an application load balancer and we want to do TLS termination, we can have some kind of ingress controller that manages certificates, or a certificate controller looking at our ingress request. It can go out and talk to Let's Encrypt and provision the certificate automatically. So based on a single ingress definition within Kubernetes, we can try and do many things. Another thing is we can have a specific load balancer controller, because if we use the default load balancer inside Kubernetes, it will direct traffic to all of your app worker nodes, which maybe is not allowed by government requirements. If you're working on government projects, they don't want traffic to go directly to application nodes. They should go to ingress nodes or edge nodes that need to have firewalls on it if you're not using application load balancer with web application firewall. For example, because in Singapore it's not available yet on Amazon. So That's one option. You can use a load balancer controller, then create a specific load balancer that only targets certain nodes, for example. So very specific load balancer control. So that's what we use in Swatmobile. We are using JetStack Cert Manager to provision certificates based on ingress requests. We are using external DNS, which is an incubated Kubernetes project to automatically create Route 53 records that point towards our load balancers. You can use, with external DNS also supports Azure DNS or Google DNS or Cloudflare or other DNS providers. So it's very extensible. And on top of that, we use Heptio Contour, which is a load balancer, which is an ingress controller written by Heptio, and it uses Envoy under the covers to route or configure the routes to route the traffic towards the services within. And the ingress controller we use is Ingress AWS controller, which is a project from Zalando, and it actually creates application load balancers and configures them. Like I said, it can control how many certificates can be set up, so you can limit the amount of hosts that you route through a load balancer to isolate your failure domain, and you can do filters, so only target certain nodes for certain traffic. So it's if you want to have a fine-grained control on the load balancer created by Kubernetes, Ingress AWS controller is a very interesting project to work with. So why Envoy? Why not Nginx? It's actually, if you look at the ecosystem of Ingress and of a lot of API gateways, for example, Ambassador is another popular API gateway, or Kong. The talk earlier was by somebody from Kong, the CTO of Kong, and he mentioned that they are Nginx based, while recently a lot of the newer projects, they're all Envoy based. And I think one of the reasons is, I think this tweet from Matt Klein is a funny reference. If you want to see what Nginx is going to do next, maybe you look at the documentation of what Envoy is doing today. So that's quite a statement. So far I have covered Ingress. I've mentioned mostly about routing and certificate management and DNS management. So how does that relate to API gateways or service mesh? API gateways do a lot more. Like in the talk earlier, what was mentioned is maybe you want to also offload certain logic, such as authentication between services or authentication of customers, rate limiting for consumers, and also provide observability of the incoming requests. So API gateways kind of come into play there to allow you to provide this additional transformation and traffic control, so you can have your backend services isolated from what the consumers get exposed to. So you can decouple how you deploy internally, how you write your services from what your end users, if you're providing an API for end users, need to consume. So that's one of the topics that was mentioned in the talk from the Kong CTO earlier, was if you're moving from a monolith towards a more microservice architecture, when you want to split up the monolith, you want to do it transparently towards the end user. So API gateways help in this aspect, right? So another maybe difference between then API gateways and service mesh is API gateways are very much focused on API management at the edge, whereas a service mesh, which is now since last year being very much promoted with things such as Istio, is where a more distributed approach of having individual, so instead of having a single proxy at the edge, having a proxy in every single of your backend services. So each backend service talking to each other also get proxied and managed through your service mesh or your control plane, as was explained by the talk earlier as well. So next, in the 10 minutes left, 15 minutes? 16 minutes. Yeah, 15 minutes left. I want to talk about a few of the cloud native API gateways. So I mentioned about Heptio Contour, which is a very basic controller that looks at your ingress requests and then generates an Envoy configuration. So Envoy has been quite a revolution in the way that traffic is being routed. So who here is familiar with Envoy, actually? Okay, just a few people. So my advice to anyone joining my company is, and anyone telling me, please, why don't we use Nginx? I know Nginx. is look at what's happening with Envoy and Istio and all of the other projects. It's a very interesting way because like Nginx was written at the time where you create your configuration and then hot reloads of the configuration has been added later on. Nginx is not written in a cloud native way. They have added a lot of new features to support cloud native deployment topology. So what do we mean with cloud native? Cloud native is an environment where deployments are short-lived, where backend services are changing rapidly. So maybe one time the service is available on one IP, the next time it's available on another IP. So the idea of the configuration of your proxy needs to be constantly changing and adapting to route traffic to different upstreams. So Envoy is written specifically for this use case. It uses discovery services to configure its listeners, its routes to upstream services, and I forgot it has 3 discovery services. And a second aspect of Envoy is it's very much written to provide a lot of metrics or insights inside how it's operating. So with Nginx, if you use the open source version, by default you get very little metrics of what's happening. If you want to get information of how much requests are going to each upstream or virtual host, you need to deploy additional components. You need to maybe use a Lua integration to expose those metrics, like with OpenResty. Kong, which is the API gateway, has actually special plugins to expose these metrics and then export them to either Prometheus or Datadog. But it's all added on later on. And Nginx itself is, there's an enterprise product, which kind of the features are maybe, if there's other companies building on top of Nginx and contributing features, how does that work with the enterprise and close-off features? So that's a bit of the concern of the community, and this is mainly why a lot of people are moving towards Envoy. And yeah. So next, Kong. So Kong originally was a traditional API gateway built on Nginx, released back in 2015. And only recently, I think October 2018, they started working on an ingress controller-based approach, where you have the Kubernetes API server and the controller watching for ingress requests, and then the controller reconfiguring the Kong gateway to handle the incoming requests of the clients to then route it to the different services that you have. So the first trend that we should notice here is that a lot of these ingress controllers support the ingress object within Kubernetes, but all of them agree that the ingress object in Kubernetes is extremely limited and is not able to expose all of the requirements. For example, it doesn't talk about how to handle rate limiting of consumers of your APIs, for example. So even though that a lot of these ingress controllers support ingress, they often extend ingress with something called custom resource definitions, which is a way in Kubernetes to extend the platform. So Kubernetes by default has a bunch of built-in concepts, but has really lived or become more popular due to the fact that they allow people to extend the platform and build in their own custom resources. So Kong introduced the concept of a Kong ingress, where you can specifically specify rate limiting and timeouts and traffic control much more in fine-grained detail than ingress itself. Then they also added a way to define the plugins. So originally Kong was very much UI driven, like you do the configuration, it gets stored in the database, and we're moving more towards like a declarative state where we put all of our configuration into a Git repository, and we version and we control and we do pull requests and we review all the code, infrastructure as code, to push the changes, the configuration changes. So instead of manually changing the configuration of your ingress, you have everything version controlled. So again, like having the ability to provide what plugins you want to be enabled on certain ingress paths is an advantage. And so bringing support to custom resource definitions such as Kong plugins, where you can specify, actually Kong uses plugins to do rate limiting and maybe integrate with authentication backends and things like that. Define your consumers, so for APIs that you expose and the credentials that those consumers can use. So that's Kong. Very exciting actually to see this newer version. Next, there is Ambassador. Ambassador has been, I don't know, I didn't look at the dates, but it's also based on, it's actually based on Envoy. The original advice from Ambassador is you define as a developer. So I think one of the main concepts here is that ingress objects allow developers to define how the mapping needs to happen to their backend services. a lot of the original API gateway solutions were focused on having a single path of entry where people, maybe certain authorities, have the ability to update the mapping and the routing, whereas a lot of these newer API gateways focus on giving the developers the ability to define how you want to route traffic by defining your objects. So Ambassador advises to do this on a service object. So they don't, and specifically by design, do not support the ingress objects because they say it's too limited, it's in beta and it may go away, and what was the last one? I forgot. Yeah, so there were 3 reasons, but I can give you 2, that they do not support ingress. So originally, like you would use annotations within services. That means you have like one service definition, and then on the service you put in text a YAML document, which is kind of concerning, because how do YAML is easy to get a space wrong, and how do you validate it? But they also support custom resource definitions, so I haven't used Ambassador so much, but I think it might be better actually to version control your mappings as individual objects, and then mappings is basically how you define your routes, and basically Ambassador translate the mapping definition into an Envoy configuration. It also supports special services such as auth, rate limit, and tracing. Not as extensive as Kong, because Kong has like a plugin model to load those authentication plugins into Kong, whereas Ambassador has a limited amount of services that it supports. Okay. Then finally, a very exciting project as well is Glue, which is based on Envoy as well. It also supports ingress. You need to enable it specifically to support ingress. Alternatively, it is very much focused on kind of defining virtual services. But what's the cool thing about Glue is it's very much focused on functional approach. So from the get-go, it's written to consider even your API or backend endpoints as functional endpoints. So you define, or it can even, if you expose a Swagger JSON or Open API spec, Glue will automatically detect what are the functions supported by your backend, and then you can define some kind of like mapping to routes that you want to expose to consumers. So the API gateway exposed to the consumers is decoupled from the functions that are called within your cluster. So I thought that was interesting, but at the moment in SWAT we are not using Glue either. We are actually using Contour, which is not really providing any of these features, but we are building a bit of the functionality of authentication currently on top of Lua. So that's where we are in SWAT. So I think my time is, I have 5 minutes left. So I'm gonna stop here. There was a lot of information. I see a lot of people after lunch getting a bit sleepy. So we are hiring at SWAT. So there's the link. I think you can apply there. I did this talk a few more times, a bit less about Glue and Ambassador and things like that. And I focused 100% on what we had as problems within SWAT, such as TLS breaking because Let's Encrypt didn't provide a certificate, or for example, a loophole when we expose the same proxy both as an internal and an external load balancer. I mentioned about like these problems in a talk that's available on YouTube, and I will share these slides maybe on my Twitter. Maybe I should share my Twitter as well. Okay. So I'll open now for questions. Do we need to pass a mic, or are you just gonna shout? I don't know.
I can pass the mic to them.
Okay, thank you for that.
So just raise your hands if you have any questions, and I'll come to you.
Yep.
Just a quick question to know how does LinkerD fit in this?
Okay. All right. Actually, I completely grazed over Istio and LinkerD. So LinkerD originally was a project created by people from Twitter, which they took the concept of Finagle, which was a library to provide circuit breaking, authentication services. So they took this because instead of integrating a library into each project, you don't, because with microservices, the projects can be in different languages. So if you have a library, then that library has to be ported to the different languages to support the protocol. So they said, how about we take that away and we put that in the data, like at the network layer. So LinkerD originally was more deployed in like a proxy at the node level. So when you deploy your application on your workers, they would proxy through the node, and then they would the node would then route based on your configuration. So you have your LinkerD control panel where you define the routes and things like that, and then LinkerD control proxy will be configured by it and route it. I think the difference is, I did mention it very shortly, that when we do like API gateway, that's at the edge, and when we talk about LinkerD or Istio, that's really like a sidecar container that's either at the node level or at the process level for the process to communicate with. So then you can control inter-process communication through a control panel and say like, okay, this service, when it talks to this one, 20% of the requests will go to a new version, for example. So you can do like shadow traffic or interesting levels between the services, also do mutual TLS. LinkerD, originally written based on the Java VM, was a kind of heavy, so it was originally deployed more as a one process at the whole machine level, instead of Istio, where Envoy is really deployed more as a sidecar. But even for that, I hear a lot of people have trouble with the scalability of Envoy taking up a lot of memory per process. So I hear that the adoption is kind of not so fluent. Does anybody try Istio, like adoption? Yeah?
Yeah, LinkerD's changed now as well.
Rust, yeah. V2.
Sorry, LinkerD 2.3 is much more like Istio now. It's got the control plane, but it mounts all the way as a sidecar and every. The LinkerD 1 is like the older version on the node level. Yeah, there's some talks about, like, I think Walgreens did a really good blog post. I think they removed Istio and they saved 10% on the hosting cost. I know from running Istio in labs, like it takes like 10 gigs of disk space and about 10% overhead on.
Right.
Yeah, because Istio installs a whole heap of stuff. I run as like ingress traffic and then LinkerD 2.3, and it's not been too bad.
Which one?
LinkerD traffic for ingress and
okay.
LinkerD 2.3.
Right.
And that's got mutual TLS and the whole stuff set up.
Right.
And it's not too bad. It's way less than 10%. But there is an overhead.
Yeah. So there was also a recent blog post from the LinkerD team about how they ported LinkerD to Rust and a performance comparison with Envoy, saying they save like 50% on memory or something like that. So Envoy is written in C++ and the new LinkerD version is in, but they don't support as many protocols as the Envoy, right? In LinkerD Rust version?
No, not in Rust.
So there's like, people maybe are holding off on moving on to LinkerD because there's a limited amount of protocols supported. But yeah, it depends on your use case. If it fits your use case, then maybe it's an interesting option. And if you don't have that many services, I'm not sure if it's worth the effort. I was discussing this earlier as well with people from OpenShift. They say also you're going to spend a lot of your infra team is going to be focused on managing the service mesh and deploying it and maintaining it. I don't think the hosted solutions are that mature in providing a hosted service mesh. Which, if that's the case, you can completely offload it. I don't know the Azure story, but
no, we just released the SMI, so we don't have a service mesh that we support. We support all the service meshes, if that makes sense. So we don't have a hosted version. We just open source the CNCF, the service mesh interface. Which like Glue and LinkerD and Red Hat and a whole other people working on. But we don't have a supported one like Google does. We don't have ClickBox or Istio or anything like that.
Yep. So did that answer your question? How does this relate to service mesh? A bit. And any other questions? Yeah.
So you mentioned Kong is based on Nginx. How does Kong overcome the challenges and shortcomings of Nginx, especially not cloud native?
In terms like hot reload and things like that, I'm not sure, but that's one of the reasons why I'm not interested in that much in Kong. Although that Kong is a very extensive platform and they are very mature. And what I think is exciting, their latest release where they really focus on Kubernetes ingress. That's interesting, but I don't, because in Nginx you have kind of two flavors. You have the pure open source Nginx, and then you have the OpenResty based Nginx which has Lua support. So I assume Kong using that to add the modules and the additional support to do hot reloads and things like that. So I haven't tested the performance or anything, so I can't say. Yeah. Any other questions, or is that it? You have, or no more? All right. Thank you very much. I hope it was interesting, and yep.